So if we understood this thing, then I'll ask you a question, and this question was asked in an Amazon interview. So it says that, hey, an array is given of size n, and I want to apply insertion sort on this. I want to apply insertion sort on this. The question was that how many swap operations will happen? How many swap operations will happen if I try to sort an array using insertion sort? So one way is to actually apply insertion sort and find out the answer. Okay. How much time will that approach take, where you actually apply the insertion sort? Can you find this out in a time better than n square? If you try to do that, then you are not allowed to, apply insertion sort, because if you apply it, it will be order n square. So can you find that out in a time better than order n square? We can count number of elements greater in left side of 5, counting inversion count. Yeah, correct. So how many of you feel that number of swaps will be equal to inversion count? Yeah, the answer is yes. The number of swaps will be equal to inversion count, because think of it in this way. See what happens in insertion sort. Let's say 7, 1, 5, 4, 11. Okay, and then 2. So what happens? The moment you pick an element, the number of swaps happening for this element is nothing but it is equal to number of elements in the left side of it, which is strictly greater than this. So for 1, 7 is strictly greater than it. So there will be exactly 1 swap for this. And now it will start looking like 1, 7, 5, 4, 11, 2. Now when you are here, the number of swaps for this will be equal to number of elements in the left of this, which is strictly greater than this. Now these elements were initially also in the left, and now also they are in the left only. They have been permuted, but they are still in the left. So the count for this 5 would have been 1, and that is the reason this 5 will have 1 swap. So it will look like 1, 5, 7, 4, 11, 2. Now when you come here, for 4, how many elements were there from here to here which were greater than that? 7 and 5, and they are still here. So 2 swaps. So basically the swap anytime happens because of inversion nature. If inversion is there, then swap happens. So I can simply say that the number of swaps will be nothing but the count of inversions. Okay, instead of insertion sort, had I asked for bubble sort? If I had said bubble sort, then what would you have done? Number of swaps in bubble sort, what would you have done? Can you tell me that quickly? Would it be same? How many of you feel like it would be same? It would just be the number of inversion count. Let's say you are applying bubble sort. Let's say you have 90, 7, 10, 14, 3. What happens in the first iteration? So in the first iteration, whatever is the largest element, that largest element goes to its reserving location, right? Now tell me one thing. If at all the process of swap is happening, that would happen just because of the fact that this element is greater than this element. Again, if the swap happens over here, that is happening because 90 is greater than 10, 90 is greater than 14, 90 is greater than 3. So the number of swaps for this 90 is nothing but it is equal to the number of elements in the right hand side which are strictly smaller than this. The same thing would happen for 7. Okay, if you take a look at this 7, okay, how many swaps this 7 will undergo? This 7 I am talking about. So if you take a look over here, at this point of time, 7 and 10 it will not be swapped. 10 and 14 it will not be swapped. 14 and 3 it will be swapped. So for 14 there was 1 swap that happened. Why? Because in the right of it there is just 1 element which is strictly smaller than it. So there will be 3 here, there will be 14 here. Now again, for this 10, how many swaps? Just 1 swap. Why? Because in the right side of this there is just 1 element which is strictly smaller than this. And again for this 7, 1 swap. Because there each element is compared with adjacent ones only. That is incorrect to say, because adjacent elements also change over the time. Array is getting modified, so adjacent elements are also getting modified. Adjacent elements are not static, right? So it is similar to the insertion sort only. In the insertion sort, the lowest, the element comes to as far as possible, as left as possible. In bubble sort, the element goes as right as possible. In both of the cases, the major thing which is guiding the elements to be pushed is inversion thing only. Because inversion happens, that is the reason shifts happen. Okay, so it will simply be equal to the count of inversions. If you are supposed to write the code for this, how's the code going to look like? So I believe all of you would have written code for simple merge process and code for merge sort, right? So what change would come over here? For the previous question, we can also use inbuilt sort function and comparator. When comparator is true, we increment the count. Can this be done? Okay, can this be done? Yes, you don't know index, and this was the thing that I had told in the comparator itself. You don't know index, and apart from that, you don't know which kind of sorting algorithm your comparator is using. You do not know whether that is merge sort or which kind of sort, right? So if and let's say if that is using merge sort, then the moment you found out that an element in the right side is smaller than an element in the left side, in that case, do you just do plus plus? Did I ask you to just do plus plus when you see that an element in the right side is smaller than the element in the left side? Others, this question is to all. Did I just do plus plus? By how much did I increment the inversion count? I incremented it by the number of elements which are in the left side which are greater than it, e minus I plus 1, right? So that is not correct what you are saying. Okay, what I would encourage you to do is, this exercise is for everyone so that you actually remember it throughout your life. Just take any random array, okay, or preferably take an array which is sorted in descending order and then dry run this approach. So create a recursion tree diagram and then see how at each level very intelligently the inversions are getting computed. Okay, so it is being returned from bottom to top and it actually works very well. Okay, so this is classical divide and conquer. Conquer is just calculation of inter-array inversion count. So how much of code change will come? See, merge sort code you have to write as it is, but now the merge procedure that you have that takes the array S1 E1, which is one sorted segment, S2 E2, which is another sorted segment. Okay, this S2 will always be E1 plus 1. Okay, now what you are trying to do is, now you have a pointer I equals to S1, J equals to S2. Now for I smaller than equals to E1 and J smaller than equals to E2. I have not written many lines of code. I have that temporary array is declared outside. So I'm just writing a pseudocode kind of thing. Okay. So now let's say what you are doing is, if you see that array of I happens to be smaller than equals to array of J. So of course you will push this in your temporary array. So let's say you are trying to merge the two sorted arrays. First is from here to here and second is from here to here. Okay. And yeah, and in the process of this you are trying to find the inversion count also. So what would have happened while you are comparing the two elements? It might happen that array of I happens to be smaller than or equals to array of J. Okay. So in this case, you will definitely push this into your temp array. Now tell me, is there a need to tamper with the inversion count if this condition is true? No, I should not do that, right? Because this doesn't say anything. This simply says that an element in the left array, which was 6, was smaller than an element in right, and that's the reason you pushed it. It doesn't mean that this has an inversion count with some elements or something, right? Because everything in the right is greater. Okay. So it is not right to say. Otherwise, what will you do? Otherwise, let's say you had a 6 over here and you had a 16 over here. Okay, then you can say that, hey, all these elements will be greater than 6. And these will be the only elements in the left array which will be strictly greater than this. So if this last index is E1, you can increment your count by E1 minus I plus 1. Just this much.